Let's use the rational zero theorem to solve a polynomial equation. This will feel like a pretty robust use of the theorem. So in the last video, we talked a little bit about generating a list of possible zeros using this idea of P over Q. And we'll start this problem the same way. So we're going to use the theorem to solve the equation 2x cubed plus x squared minus 4x plus 1 equals 0. And I'm going to keep the same color scheme going to find our factors of P over Q. So it turns out we care about the factors of the first and the last numbers if the polynomial is in standard order. So let's generate the list of possible zeros as a starting point. And notice this example really asks us to use the rational zeros theorem to help solve. So it means that we might have to rely on some other techniques once we get to a certain point. So we're going to use this idea of P over Q. So P involves the factors of 1, right? In this case, I've circled 1 at the end there. So the factors of 1 are not too extensive. Plus or minus 1 will do. Q will be the factors of 2. So for factors of 2, we get plus or minus 1 or plus or minus 2. So our list of possible zeros is not quite as extensive as our last example. But to continue cleaning up this list, I could take the plus or minus 1 divided by the plus or minus 1 to get plus or minus 1. I could also take the plus or minus 1 divided by the plus or minus 2 to get plus or minus 1/2. So how many possible zeros does this mean we have? This means we have really in total 4 possible zeros. So if it's hard to see the 4 zeros from the way I just listed it out, it would be just as good to list out the plus 1 and the minus 1 separately, the plus 1/2 and the minus 1/2 separately. Now these are possible zeros, so often there's a misunderstanding that these are the zeros, but notice this polynomial function is a degree 3 polynomial, so we know there aren't more than 3 zeros anyways, and they might not all be rational. So this list involves more zeros than are actually going to be true of this polynomial. So now we just have to figure out which one or ones work. And this is where we get kind of a trial and error approach. The more you do it, sometimes you get a little bit of a feel for which of the possible zeros would be good to try. But all I'm going to do is run through these zeros, and I'll just go through them in order. Actually, this is kind of funny. So I'm gonna do this only because I don't want to get the right zero right away because I want to show you more of the trial and error process. So I'm just going to reorder my list for fun and ask us to move through this list one by one. So first we're going to try a zero of -1, see if that is in fact a zero. It's a possible zero. And then if that doesn't work, we'll move on to 1 and so forth. So how do we check? How do we determine whether these are zeros or not? Well, we actually just bust out our good synthetic division, right? So let's begin by trying x equals -1. So if we synthetically divide by -1 and we get a remainder of 0, that means we've found one of the zeros. If the remainder is not 0, we're going to guess again. So inside the synthetic division, make sure you have this problem written down for yourself. I'm just going to place 2, 1, -4, and 1 as the placeholders from our given polynomial function. So make sure you have written down your 2x cubed plus x squared minus 4x plus 1. So my 2, 1, -4, 1. We've practiced synthetic quite a bit by now. And to run through that process, I always drop the first number, multiply that result by the -1 out front, which gives us, if I can change my colors back real quick for you, -2. So we'll add down that column. 1 plus -2 sounds like -1. I'll multiply that by the -1 out front to get +1. I'll add that in column 3 to get -3. I'll multiply it with the -1 out front to get +3. And when I add, that means my remainder turns out as 4. All right, so 4 is not 0. So the remainder is not 0. So that means x equals -1 is not a 0. So x equals -1 is not a 0 for the polynomial. So that's okay. We just got a little extra practice with synthetic division. So now I'll just continue moving through my possible zeros. So we tried -1. It didn't work. Let's try +1. So same as before, to try x equals +1, I'm just going to set up the synthetic division again. So we're going to place the 2, 1, -4, 1. This time we're using +1. And we'll just show that process again. So drop the first number, multiply that result by the 1 out front. That gives us 2. Add down that column to get 3. Multiply with the 1 out front. That gives us 3. Add down this column to get -1. Multiply with the 1 out front to get -1. Add those results and we get a remainder of 0. So I don't know about you, but sometimes this process is kind of tedious. So when I get a remainder of 0, finally, I feel pretty happy because I could have had to try more zeros even to get that remainder of 0. So just be patient. A lot of times we have to be fairly persistent in math to get to the result that we need. So at this point, this means that x equals 1 is a 0, right? So to interpret all that we just found, we can say, so x equals 1 is a 0, and from our factor theorem, that implies that we also know the corresponding factor. So what would be the corresponding factor? That would be x minus 1. X minus 1 is a factor. So from our original, f of x equals 2x cubed plus x squared minus 4x plus 1. We can now say that it factors to x minus 1 times whatever was left for our synthetic division, which you can still barely see on my screen here. So I'm going to have a 2x squared plus 3x and a minus 1. So times 2x squared plus 3x minus 1. So interpreting what's left. Ooh, so we're making good progress. Let's go back and check out the directions for this one and see if we're done or if we still need to go a little further. So what was our goal here? Our goal was to use the rational zero theorem to help solve the polynomial equation completely. We found one solution, but there are technically 2 more solutions. So I'm going to keep rolling on the next page. Let me just rewrite where we left off. We had found that our polynomial, a little bit of rewriting from my very last line, you maybe already have this written down, factored to x minus 1 times 2x squared plus 3x minus 1. So far I know 1 0, but this piece here has 2 more zeros hiding out. So let's think about for a moment whether that factors or not. This is a little harder to factor. So using whatever factoring technique you learned in your earlier algebra days, I'm actually thinking about it as, is there something that multiplies to -2, which is the product of the first and the last, so factors of -2. Are there factors of -2 that could add to the 3 in the middle? If so, it factors. If not, it doesn't factor. So here are the options for multiplying to -2. Unfortunately, neither of those options could add to 3. So what it means is that this trinomial here doesn't factor. That doesn't mean we're done with the problem. It just means that the remaining 2 zeros are not rational, right? So if something doesn't factor, then it's going to mean that the zeros are not rational. But what other ways do we know to solve quadratics? Probably you've used the quadratic formula in your previous algebra course. So to finish solving this, I'm just going to go ahead and use the good old quadratic formula. So let's go ahead and use going to abbreviate quadratic formula to solve this remaining piece, 2x squared plus 3x minus 1 equals 0. So the quadratic formula, again, in general says you do negative b plus or minus the square root of b squared minus 4ac all over 2a, where a is the coefficient on x squared, b is the coefficient on x, and c is the constant term. So I'll just apply the quadratic formula to our problem here. That means I'll get negative 3 plus or minus the square root of 3 squared minus 4 times 2 times negative 1, all divided by 2 times 2. So I'm just carefully plugging in our values for A, B, and C. And I'll just continue simplifying for a moment so that we obtain the two other solutions here. All right, continuing on, we get negative 3 plus or minus something under the radical divided by 4. Under the radical, I see a 9. Let's see, that would be a plus 8 if I'm careful with my signs. 9 plus 8 sounds like 17. So there are the other two zeros for this polynomial. These are irrational zeros, you can tell, because the square root of 17 doesn't simplify. So let's summarize what we just found, because there's kind of a lot there. So we were solving 2x cubed plus x squared minus 4x plus 1 equals 0. We know there should be 3 solutions based on the degree. And the 3 solutions we found, first we found the rational solution. And we obtained that rational solution by using the rational zero theorem. So that first solution was x equals to 1. Remember when we divided synthetically by 1? Oh yeah, that was on our last page. We were able to get the remainder of 0, and that was a good thing. Then we used the quadratic formula to finish off the last 2 zeros, and I'll bust them out as 2 pieces just so they feel like 2 more zeros. So we get negative 3 plus square root of 17 over 4, and then we get negative 3 minus square root 17 over 4. These are the 3 solutions to the given polynomial equation. And I would highly recommend graphing and double checking in Desmos. It's super easy to make sure that if you plug this in, you will find the x-intercepts at these 3 locations. So we'll do one more example because this is a little crazy. So one more example coming up in the next video for the rational root theorem.